All right. All right. Afternoon. You'll see now online. All right. Nice. So you want to do a quick. You want to do a quick run through of what we did before, and then you want to continue with this analog part, right? All right. So. So on Saturday we started up amps, right? We started up amps, and within the up amp we talked about gain that gives you an idea of how the up amp is amplified, right? Right? We looked at how the up amp is amplified. Gain was output over input. Output over input, and we looked at how to find gain. We looked at how to find the maximum minimum input that will not cause saturation. We looked at the graphical side of it. This here is the graph of output versus input for any up amp. And then the last thing we looked at was the comparator, right? Remember what the comparator did? It compared the inputs, right? The comparator compared both inputs and figured out what the output was. So for example here, when we worked out the potential at both points, we recognize that the inverting voltage was 6.7 and the non-inverting voltage was minus 4.3. So the inverting more than the non-inverting and saturate low, right? That's what we did Saturday. Okay. Right? So that was what we did on Saturday. That was comparators. So now we're going to move away from comparator. Oh wait, no. No, we have one more type of comparator to do. Right? So remember what the comparator does, right? The comparator takes the non-inverting input. It takes the inverting input and it compares it to give you output, right? And we said that if the inverting is more than the non-inverting, it will be minus Vs. If the non-inverting is more than the inverting, it will be positive Vs. Good. That's what we did last day, right? Right. We only did the calculation type questions. Didn't get to do any graphical type questions. All right. So let's take a look at the comparator using graphs now. So watch this here. Here's what we're gonna look at. I'm going to give you a signal looking like that. That'll be a non-inverting. And then I'm gonna give you a symbol to make it simple. I'm gonna give you an inverting voltage like that. You have to compare both of them and then figure out what the output is graphically. Okay, so just head up just a small heading graphical, the graphical version of the comparators, right? Not of the comparators, but I gave you calculations before. Now we just going to take a look at a graph, right? I'm gonna just get a graph page. Make a note of this in case you forgot it or you didn't write it down or you can't find where you screenshot it. All right, so we're going to do the same thing. We're going to compare and try to figure out what the output is. All right, but I'm just trying to get a graph page, right? I want you all to see it properly. This is the most important thing, right? INV. INV means inverted here. NON is in non-inverted. You're sleeping all day? You're sleeping at the beginning too? You're sleeping for the whole class?
No, it's to me, couple minutes after I was still here.
Oh.
After that, I just one more after that.
All right, so let's go. All right, I'm trying to get a graph page here. So give me 1 second. Well, a graph page with no lines, it doesn't have lines. All right, don't worry with the scale, right? I just need the graph here for the lines. All right, let's take a look at it. So I will tell you which is which, right? All right, so what is here? Let's say I gave you a comparator, and for the comparator, the supply is plus and minus 8 volts, right? The non-inverting is 2 volts all the time, right? So I'm going to draw a red line here to represent the non-inverting. The non-inverting is, oh wait, no, that's not red. Yeah, a red line to represent the non-inverting. Okay, and the inverting is a signal that will be alternating, right? Let's say alternating 3 volts is an alternating supply, right? So you're going to look something like this, right? 3 is like the middle here, right? So it's coming up here to about 3, coming back down. Let's make it bigger so I have less to do. Come up here till about 3. And then it coming down here till about 3. All right, no, it's not perfect. Right, but here we have the inverting voltage and we have the red, which is the non-inverting voltage. Right. The difference here is that the values changing for the inverting but it's remaining the same for the non-inverting. What we have to do is figure out what the output looks like. Right? So what you do is you'll be comparing. Compare the red line to the blue line and see who larger. Right? But before you do that, what we need to do is to highlight the points where the red and blue meet. Okay? So let us use a yellow line. So let us say it meeting it meets in there. It meets in there. You don't have to draw this, but the reason I'll draw it is because it just shows you where they meet. So you'll know what's happening. You'll know where to draw your lines. And it'll be easier for somebody who correcting to find everything. So between those lines, we are going to compare what is happening with the inverting and the non-inverting voltage. Good, let's see if we can figure out that now. I will do this in green, hopefully all will see it. Right, look at the first phase, that's right here. That's right here. Which is larger, the red line or the blue line? Which value is larger there in the first phase? The red line, right? And the red line is the non-inverting. Everybody okay with that? So the non-inverting is more than the blue line, which is the inverting. So if the red is more than the blue, will it saturate high or low? Check and see. If the non-inverting, which is the red, is more than the inverting, will the value be positive 8 or negative 8? Sorry? Positive 8. Online, you remember that? Nice. So it will be positive 8 here. So I'm drawing a line to show positive 8. Okay? Now we're comparing the blue and the red line. Which is larger? The blue. So the inverting more than the non-inverting. Will it saturate high or low? Low. So the value will be negative 8. That's okay? Which is larger in the next phase now? Red or blue? So it will saturate high or low? High. Positive 8. Any questions online? Next phase, low. Next phase, high, low. That's the way to look. So the green lines are the output. The yellow is just helping you to separate them. Any questions online? Are you okay with that? So that's the graphical version of it. Okay? Yeah. Yeah. That's why I gave you the two versions. I'll show you one in a little one. Well, that's what I was supposed to finish up Saturday. Right? So copy that down. You have to draw it. Take a picture, draw it. Draw it in quick. And the reason the yellow lines are there, the yellow lines lets you know that within those regions is where you have to compare. Okay? Finish? Finish? All right, so good. So that's the end of the comparator. Now I want us to look at the two next types of gates. Op amps. Anybody remember the names? There were two other types of op amps. One was the comparator, and the next two was what? The anybody remember? Right, the next two were the potential values where you connect up the comparator to. So the next two are inverting and non-inverting op amps, right? And these, as the little thing suggests there, these are feedback, right? So you will see, right? This is an example of what we were just doing, right? That's a comparator. What you will see now is a resistor looking like this. Sorry, a op amp looking like that. Once you see that, that is an inverting op amp, right? And then I'm going to show you what the non-inverting looks like. Just notes mixed up, but that's why I didn't send it. All right. So the last two op amps look like this. This one is the inverting. I'll draw it for you. And this one is the non-inverting. Right. So what you there? Right. If you look at this circuit here, this is an inverting op amp. Right? An inverting op amp, how you know it? There are two main features. The first feature is that the non-inverting terminal connected to it, right? And there's a feedback resistor. So the output being fed back to the input. That's okay? The output is being fed back to the input. So that is what your inverting op amp will look like. You will notice clearly that the input is connected to the inverting terminal. That's why it's called an inverting op amp. On the other hand, the non-inverting op amp right? The non-inverting op amp looks like this, right? How you know it? Again, there's feedback. There's feedback here, and the input is run through the non-inverting terminal. Notice this is inverting input. This is input, right? I just look at the abbreviation, right? Yeah, so basically that is what your two types of op amps look like. Inverting and non-inverting op amp. Okay, so just look at where the input coming from. If the input coming from the inverting or going towards the inverting is an inverting op amp. If the input coming from a non-inverting is a non-inverting op amp. See that? So you had to be able to identify each one, right? And of course, we had to be able to find the gain. We had to be able to prove this formula as well. Gain is equal to minus RF on RI here. And here, the gain is equal to 1 plus RF on RI. Okay, copy them down. Come on, Lee. Got a little join there. Gotta get used to drawing up. Oh, I think it give you a little rest. Tum, 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 tum. He didn't show anything now, boy. It's a fucking boy. You see that? I was near a pump is an amplifier. So it takes an input and gives you takes a small input and gives you a large out. And have you record that class, huh?
Yes.
I recorded. So these are the last two types of op amps. We had to be able to work it, right? I am going to show you how to prove the first formula for the inverting, and you will have to try to figure out how to prove the gain for the second one, right? Am I ready? So does RF mean, RF means feedback resistor. RI means input resistor. You don't have to call it RF, you call it R1 and R2 if you want. So we're going to try to prove this formula for gain. Any idea what formula we're going to use to start off with? How are we going to start this proof? We want to prove gain is equal to minus RF and RI. What do you know about gain? Gain is what? I want to ask Andy what I would. I remember what is gain? Right? Gain is B out and B in. Good. So that's where we'll start. We'll start with gain is B out and B in, and we have to figure out how to get B out. We have to figure out how to get B in. Right? I want to erase the non-inverting. So what did you write in the end of the second diagram? B out. That's B out. That's what I mean, B out, right? Okay, so sometimes in questions, they'll ask you to prove that. Okay, I erasing it, right? But it was not finished, just screenshot it fast. Right, so this is kind of assuming that you'll this is kind of assuming that you'll remember. Okay, anyway, so let's take a look at it. So first thing first, anybody remember what was one of the assumptions of the op amp? Open loop gain was infinity. Those things, I remember that. Open loop gain is infinity. Input resistance was infinity. Output resistance was 0. I remember that? Right. So let's pretend you remember it, right? The resistance here really high. So if the resistance there is really high, what that means is that little or no current will flow here, right? So little or no current will flow there. So what it also means is that this point here, X, that point X acts as a virtual Earth. It's not actually Earth, right? But because of that assumption, we call it virtual Earth. Because the voltage here will be zero. Nothing will flow back there. Nothing will flow between X and here. Right? So that feedback, so that X there represents virtual Earth. It's a 0-volt point. That's okay? You done? The resistance here really, really high. That's an assumption of the op amp. Because it's so high, no current will flow here. So that X point is 0 volts. Right? So we call it virtual Earth. It's not a real Earth. Real Earth is like this. That connection means that that point is really Earth. Okay? Right. Next thing we need to know is that current will come back here. Current is fed back there. Let's call that current I. Look at the path that current will follow, right? It will go here. It will go through there. Where will the current go next? Would it pass X and go to the right? No. It will go to the left here, to the left. It will follow like that. It will flow like that. That's okay? Current will flow there in that circuit. So what we could say about RF and RI, they are in what? What connection? Series or parallel? They are in series. Nice. They are in series. Okay, good. So we have some hope here. We might be able to set up this circuit, right? Before we do that, I want to connect 2 voltmeters. I want to connect a voltmeter here and a voltmeter here. Let's call that value V2. And I want to connect a voltmeter here, and I want to connect a voltmeter here. You'll see that? Quick question. What will V2 measure? A voltmeter always measures the difference in potentials, right? It measures the higher potential minus the lower potential. So V2 will measure V out minus Vx. Okay with that? But Vx is how much? Vx is 0. So really and truly V2 measuring V out. What about V1? Right? It'll be Vn minus Vx. But Vx is 0, right? So it really measuring Vn. Everybody okay with that? So we'll be going good so far. Nice. Let's just quickly see if we can find V out. Remember, V is equal to IR, right? Oh, Andy here too, boy. So V out is what? I just find V out again. Right? V out will be the voltage across V2, which is current by the resistance. Are we okay with that? Current is I and the resistance is RF. Now Vn. Vn is V1, which will be the current I, because the same current I going through Ri, correct? So it will be I by R, which is I by IR. And we said that gain, is equal to V out on Vn, right? So that will be IRF all over Ri. All to the I's. So you will get RF on Ri. Where does the minus sign coming from? The formula is minus RF on Ri. Where does that minus sign coming from? Huh? Kind of. Remember, it's an inverting op amp. So the inverting op amp will always change the fields, right? So that negative sign comes in because it's an inverting op amp, right? In the proof, I can already correct the current direction, but really and truly the current going in the opposite direction. That's where they get the minus sign from. Okay, so what you have in front of you there is the proof for the inverting op amp. You got to be able to do that for yourself. Okay, copy it down. So the minus sign comes from the fact that it's an inverting op amp, which means that it will always be opposite in phase, output and input. So they should have a negative sign right here. Online, follow okay there? Shivani, Renel, Rahul. So the main proof is you need to know how to get B out and B. Finish. Finish. Yeah. Anybody writing online? So good. So that's a little proof, right? Let's do some calculations on this now. Get his graph here, please. Get your graph of B out versus B in.
So, the top sketch table, we see 10. There's a stuff.
Kilo ohms, yeah. Yeah, so it's just yeah. What one? That look like a resistor?
Huh?
That look like a resistor?
Sorry. Diagram itself, there's just stuff. I don't know.
Right, so what I want you to do for me is sketch out, please. Sketchy B out versus B in.
That's true. And we go, oh, so. Yes. What's all right? I'm here for. Sex. What the hell is, I do. Something that you like. Yes. Sketch. There's that. Oh, I mean, like, you heard something like. Oh, that is the power. And then he can listen. Yeah, but prior to this time. There we go. The other one first, I thought, yeah. I was. Be not. Oh, I guess it's not. You came up that. Is that in place? No, you know, I need to grab. We need. No, I'm not gonna stop. It's too cool. Yeah. Just like how you call that SAT. I don't know. So what you did nothing. This is not stop. This is what we just do. Figure out.
So how you find gain? So you need gain first, right? How you find gain, Andy?
Negative R.
So that's negative 10 on 2. So the gain is 5. Of course, it'll be much bigger than that, right? But the gain is 5. Nice. So we have the gain. Remember the sketch? What's the general shape? Anybody remember? What's the general shape for inverting up arm? What's the general shape for the graph? Everybody see? So you basically need those values, right? So you need V out, you need V in, right? We already know the maximum is positive 10, minimum minus 10. We need the input here. So to get the input, we're using the output, which is the supply over the gain, as the formula I gave you last day, right? So that's plus and minus the supply all over the gain. So again, plus and minus 2 volts. So minus 2, positive 2. Anybody got that graph? Nobody got it? Somewhat. Yeah, okay. So when I say the V out versus V in graph, that's what I'm referring to, right? How we know the graph shape like this again? How we know it's on this side? The reason we know it's on this side is because a negative input, positive output.
Yes.
Negative positive. If it were non-inverting, it would be on the next side. So you recognize here that we have the ability of actually working out the gain, right? And then using the gain to find the maximum minimum input. Right? So the shape of the graph is the same all the time. Just have to figure out which side it's on and then plug in the values. Karina, you okay with us? Okay, next one. Sketch out there. Let's change out the values. Since y'all do remember what we did Saturday. I think when you were hot sun, I take for that class.
Outside?
I was outside South Park here.
Which we do it itself.
Well, that's a little chess tournament now. So I was trying to watch them play. So I was sitting down outside teaching and someone was real hot boy. I couldn't take it. What time was it? About 12 hours top end?
Yeah.
Yeah, I couldn't take it no more. And if I move, the Wi-Fi cut off. So every time I move to go and watch them play, it cuts it off. I couldn't even go with that sheet and if I went down in Starbucks, I wouldn't be able to see anything. That sound was real hot, bro. Oh my gosh. I didn't already even pay attention. Should I just cancel that class? They were just trained for something. I could not play whole day, every day, same thing over and over. That's why I study for exam too. And the good thing is, you know what his sketch will look like, right? All right, we have the values. Eden, help me with this one. Finish it. What do you get for the gain? Eden, what you get for the gain? 25, nice. What you got for the max or min BN? That's the second part, Eden. So it's plus and minus 15 over 25. That's what, 0 point something, 0.6. Oh yeah, finish it quick. I give you 2 minutes, finish out that. And then do the sketch. Right? Do the sketch yet? When you finish, let me know online. Right, should be done by now. Max or min is plus or minus 0.6 volts. Right? So here'll be 0.6 as a minus. Here'll be 0.6 as a plus. The maximum V out is 15 volts. And the minimum V in is minus 15 volts. So that's what your graph will look like. Keshav, get up. Anybody got it online? Right, so you see how similar the shapes are, right? Phoenicia, you getting through there? You got a graph there, Phoenicia? Okay, so that's just a general shape, right? Quick question. What will happen? What will happen if the VN value is 0.7 volts? What will the V out value be? If the VN value is now 0.7 volts, you can see it on your graph. Positive 0.7. Eh? What will happen to your V out? What value will it become? Look at your graph. Plot 0.7 and try to read off what you're getting for the output. Negative 15. And what saturation happened? If it goes over 0.6, then it's saturated. So the value is negative 15. So saturation occurs. And the value is minus 15 volts. What will happen if the value for Vn was negative 0.8 volts? Andy, what will happen if it's negative 0.8 volts? Right, so saturation, right? So it becomes positive 15. So it's saturation, and the V out will be positive 15 volts. Okay? I think remember that, right? Rahul, you okay with that? So once you go outside of the inputs, plus or minus 0.6, saturation will occur. Saturation means that you could only have an output that'll be plus 15 or minus 15. Okay, nice. Any questions there? I'm gonna see who there. Who most likely sleep away here, right? Huh? George, you there? George. All right, just making sure you're awake there, George. Right, nice. Here's what I'm gonna do now, Aiden. Tell me what you think we could possibly, how we could deal with it. I'm gonna connect two up amps, two inverting up amps. Right? The output from one will be the input for the next one. Right? So the output from one will be the input for the next one. I want you to try to figure out what the final output will be and what the overall gain will be. So what you are gonna do, right? I am going to connect two op amps just like this. Right. So what you say? Here we have two op amps connected one next to each other. They are called cascade cells. Right? This is called cascade. Is called a cascade circuit, right? Right. We need to figure out how we're gonna get the final out. Normally we can do gain, right? But we don't know gain here for the total thing. So we need to find a way now to use the input of 0.5 volts, right? Use the input of 0.5 volts to see if we could figure out. Hold on, let me just make sure this. I'm gonna just go a little bit smaller just in case I cause saturation. All right, so there's a good value, right? 0.5 should be a good value. Right. So my question here is, how am I going to work out that V out value? Any ideas? Before I leave it to do it. Any ideas? How we could get that final V out? So let's do it in phases. Can we get this value here, the first V out?
Yes.
Yeah, because we could work out the gain and we could find V out, right? We said that that V out is the same as the V in, the second V in. So if you know your second V in, can you find your final V out?
Yeah.
In a similar way, right? So I would like you to find V out, the final V out, and the overall gain. Try that, please. Try it, please. Online, see what you can message your values. Message your value I got for V out and gain. Right, message your V out and your V in begin. Everybody here, Rahul, you too. Message some answers. George, send me some answers now, please. Please, please, please. Oh, Shabara, not there. Time for the first V in, first V out, and then go for the next final V out.
We're getting a second. It tells you. I don't know if you will say that. Much in practice. That's what. It's more than something.
Right? How much you got?
100.
Something do wrong then. I give you a bad value. Huh? Yeah, try some a little small. Anyway, let's use this and see if we could fix it. So first thing first, yeah, I shall work out the overall. I didn't work out the overall. Anyway, let's work out the gain of the first one. So this is A. That's the first and that's second, right? So the gain is equal to minus 110, which is 10. So therefore, the V out will be minus 10 by 0.5, which is minus 5 volts. That's okay? That's the first V out, minus 5 volts. And then gain 2 now, that will be 500 over 20, which is 25. Right? Again, it's minus, so it will be minus 25. Are you okay with that? So therefore, the final V out will be minus 25 by minus 5, which is 125. Okay? But the problem is that saturation. So therefore, the value will be 15 volts. Sorry, 10 volts. Because of saturation. Okay, 10 volts. Right. How you would normally get the overall gain? Normally, the overall gain will be the final V out over the V in. So it would have been 10 over 0.5. Okay. But I gave you a kind of bad example, so you mightn't get what the correct answer is. So how do you find overall gain? I'm writing it in red for you. Overall gain for a cascade circuit is gain of the first by gain of the second. Gain of the first multiplied by gain of the second. Right? That's for a cascade circuit. To make a note of that, gain for cascade circuit is A1 by A2. Right here done? Sure. We have one application of this to do, right? I don't want to break, I want to finish it. Take a break, take a little break. Take a little break and then we'll finish up that one more application. It's called a summing amplifier. Right, take a little break, 12 till half past. Till half past 2, right? Take a little break till half 2, and then we will do something called the summing amplifier.
Alright, fine.
Right? Take a little break. All right, let's go again. All right, so let's see. Yeah. All right, let's start back there earlier. Right, I know I didn't really do the proof for non-inverting yet, but you have to do that for homework. Right, for homework, I want you all to do this summer, please. Try and prove this for homework, please. All right, so I want you to try to prove that for me. All right, so good. Before we start, I want to run through this quick, and we're going to take a look at cascade cell with all three in it. Okay. So remember, how do you find gain for inverting up amp? Minus RF and RI. How do you find gain for non-inverting up amp? 1 plus RF and RI. That's okay. How you know which one is which? How you know which one is which? Right. So it's based on where the earth connected or where the input is run through. So if the positive, so if the non-inverting connected to earth, it's like inverting up amp beta. And if the inverting connected to earth is a non-inverting because the input is run through here. Okay, I'm going to give you a cascade cell now. You have to figure out which is which and then find the appropriate gains, right? Judy, could I close that door there, please? And just make sure you look outside for a minute. Okay, so I'm going to give you a cascade cell here. Right, try the proof earlier. Try the proof and see what you come up with. Homework. All right, this one here have 3. Do I want to give you 3? Nausea. All right, yeah, sorry, I lost the page for the 2. Oh, look at it. I got the 2. This is 2006, right? But the problem is I can't take a picture anymore. All right, you'll see this here online. All right, hold on. I do think it's showing up. Try the first part. You'll see it there? It's a little dark. Online, you'll see it, right? It's a little dark, but that's the first part. Find gain A and find gain B.
That's the story.
2006 paper 2 what? Then the first example is a what? Non-inverse, non-inverting. Yes. A is a what? What type of example is? Inverting. The negative connected to it, see it going down to 0. And the input run through the positive. See that there? The input is run through the positive. So it's a non-inverting. Right? What about the next one? Shivani, what type of op-amp is the next one? A was a non-inverting and B is a what?
It was a.
A was a non-inverting. Look at that good.
Oh, wait, sorry, yeah.
Shivani, you there? And B is a inverting. Inverting. Because the positive terminal is connected to the. Actually, you know what? I should have given you all that question. Right? So here we have a non-inverting. Here's an inverting. Find the gain of A, find the gain of B, and then find the gain of the whole thing. Right, there's a question I have.
Yeah, because one of us are. Right, so train on good, I want to be to always walk us the other. What? The game was not. So I'm all out, you know, I'm getting it, I'm sure it's young. I didn't get to the. Yeah, I took a little better. You multiply that. Oh, yeah, we all just. Still want to. All right, so this 6 by. Sure. I'm trying to pass it. At what point in months did you start construction of mountains? In 2.5. You do not 2.5. start at the point, but only contract can only have contract 6 weeks. If you want, but oh, there's one thing to do that. I do not know. I need to say how important you got a point. That's good. I need to take your idea, so I do not to do it. So, you still know. Why do you take your your son did? Did not this. People downstairs, people start to understand that they could be fast, fast, but just rejoin whatever we give for. That's the same thing. Not for really. So, lady. Yeah, it's good. This is entirely different.
Yeah, we all got. Still have one data. So work out the gain for A, work out the gain for B. All right, let me check it out there. So gain A, we said a non-inverting. So that'll be 1 plus 50 on 10. So that's 6. Gain B, that'll be minus. Don't forget the minus, 300 over 150. So that's minus 2. So the overall gain, as gain of AB, will be 6 by minus 2, minus 12. Yeah? Minus 12. Nice. Any questions online? Good job, Katrina. Right, but it's minus 12, huh? So overall, you'll get a negative output. Right, Andy? Still have 2 more little parts there. Let's finish that now. Mark X to represent any virtual Earths and find the output. So on your diagram, mark X for any virtual Earths and then find the output when the input is 0.3. Finish last two parts. So where the virtual alert is? Where the virtual alert is, Andy? But where the virtual alert? How much it have? 2 points, right? Yeah. Tell me where.
Alright, so I can't explain it, but yeah, you see, R2 is till left, go down, but that's one, and then R4 till left, go down, and one there.
Yeah.
Yeah, there.
Yeah.
No, the other side, the other side, the left side, yeah.
Yeah, correct. Actual alerts will be like down here, right? Down at the bottom. Yes, those are virtual alerts. And then they want the output when VN is what, 0.3, right? So that'll be 0.3 by the overall game, which is -12. So that's what, 3.6?
Yeah.
-3.6, right? -3.6 volts. Nice. Good. Any questions online there? Shivani, you okay there? Rika? You good? Okay. Just one more. One more cascade, and then we do the last. We do the last type. Sorry, not the last type. We do an application of the inverts in our power. Last one. Find the net gain. This one is 3. But you have to figure out which is which, right? And then we do something simple called the sum and amplify.
We don't know the
2003. Trying to avoid it after the graphs. Sure. Finish your thing already? Right, message answer me done. Well, sorry, finish this one, right? Message answer on the finish. No answers online? I said earlier. Online anymore? Katrina? Oh, Katrina, you sent yours. Okay. Celine earlier. Anymore? Oh, all right. So let's go gain here. Gain on the first one. That is a non-inverting op amp. 500 and 100. That is 5. Next is the inverting. Sorry, plus 1. So that's 6. Right? Right, sorry about that. That's plus 1 actually. Next one is minus 500 over 50. That's minus 10. The last is the same thing. So that's minus 1500 over 150, which is also minus 10. So the final gain will be is a cascade. So it's 6 by minus 10 by minus 10. 600. Yeah, nicely done. Good. I like to see that here. So output is 0.01 by 600, which is 6 volts. Right? Well, they didn't give us any saturation values, right? So we don't know. Right? Looking like saturation. That's okay. Nice. So last thing we have to do. Last thing that we have to do is something called a summing amplifier. Right? A summing amplifier is an application of the inverting op amp that allows you more than one input. So for example, if you have more than one input, so let's say you have input 1, okay, sharp, let's say you have input 2, let's put 3 inputs. Last thing, right? Let's say you have three inputs. You have an input voltage 1 here. You have an input voltage 2, 3. Resistor 1, resistor 2, resistor 3, and your feedback resistor, right? What this circuit allows you to do, it allows you to take three inputs and give you one output, right? An application of this is in a mixer, right? A mixer will take like a microphone, right? It will take other device that to give an input and mix it to give you one output. Right? So here you have three inputs, V1, V2, V3, and all is going to give you one output, right? How are we going to get that now? So the one output, I wouldn't make it prove it, right? So the one output is given by this minus RF on R1 multiplied by V1 plus, well, sorry, minus. So basically, you're finding the output for each one of the inputs. How you find outputs again? Output is input by gain, right? So you find the gain using each one of the resistors and multiply it by each one of the inputs. So it's RF on R2 by V2 minus RF on R3 by V3. Okay, that's just sum and amplify. Three inputs, one output. So we could alter V1, V2, V3 and get different values for V out. Okay, and please note that this is a inverting op amp, right? You're seeing why, right? You'll identify that inverting, right? Yeah. So it's an application of So let's use some numbers and fill one now.
So it goes.
Close.
So.
Yeah. That's all. It's up till you reach. That's almost done. Huh? I think she have it open. If it closed, you could go there. Right, so that is your summing amplifier. Let's put some numbers to it and see if we can design one. So in 2006, that's the same year we did earlier. Look at what they gave us. They gave us 3 inputs, V1, V2, V3, and it could be combined to produce V out. They told us that we could use, they want us to design a circuit to achieve this using resistors between 15 and 200. So of course we know there's 3 inputs, 1, 2, 3. Right, we don't know any values, right? Right, we know this circuit is an inverted. Right, we have V1, we have V2, we have V3, and we have V out. We need to put in some values. We know the circuit, but we had to put in some values that'll give us this. Hello. Okay. Right? What y'all think? What are some values between minus 15, sorry, 15 and 200 that could help give us -2, 8, and 1? That's 1 there, right? How are we doing that? You can use any values you want, once the values are between 200 and 15 kilo ohms. Copy down and think about it. You want to put values for these resistors here. Well, what's the formula? Yeah? Remember the formula? The formula is minus RF on R1 by V1 minus RF on R2 by V2 minus RF on R3 by V3. So we're not really allowed to change RF. RF is the one that's the same on all the formulas, all the little fractions. We need to get some values for each one of them. Last thing and we're done. George, any ideas? Last thing and we're done. We just need some values to put in there. I'll just give you like an example. This first one is 2, right? So it could be 100 over 50. But you have to get 8 and you have to get 1. Think about what values you could use. Dun, 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 dun. Any possible values? The average is the same value. So the top of the formulas will be the same. To be honest, you can pick anything. Huh? Who want to pick some for RF? Yeah? 200. Jude said to pick 200 kilo ohms for RF. So what would the resistor next to V1 be? 100, because it has to give you 2, right? 200 and 100 is 2. What will V2 be? 25. Very good. 25. 25 is more than 15, so we're good to go. And the last one is what? 200. 200. Right? So that circuit there will give you it, right? Check it and see. Check it and see. Minus 200 over 100 by V1 minus 200 over 25 by V2 minus 200 over 200 by V3. So you'll be left with minus 2V1 minus 8 V2 minus 1 V3. That's it. That's what you want to get. Okay, so that's a summing amplifier, and that's what you have to be able to do. You have to be able to draw it from the formula, and you have to be able to take the circuit and create the formula. Okay, so that's it.